Right folks, well, you've just missed the event of the century because the batteries are flat in the camera system remote. I've just unsealed a sealed box York 863. So I'll show you the box later. I've taken the lid off, written down the serial number, and what I was going to do is to bring it up slowly because it's 40 years old and it's new, and I want to see if I can get the camera 6 to actually go to our power supply. So that was where I was. Yes, I can. Okay, so we're now on the power supply, which I'll switch on, and we'll select 8.5 volts, and we're going to current limit it. Just move for it in a moment. We're going to current limit it to 300 milliamps, like that. I've got the standard Cybernet mic out, and if we've got one on the bench, we will use, we should have a little Cybernet stub on here because I don't want to undo the customer's. So what I was saying, which you've missed because we weren't recording, I've got a lovely 4 minutes of blank. What I was saying, I'm going to have to get a lead out of stock, is it's all well and good having new sets in boxes. A lot of the sets which look like the new in boxes turn out to be returns. This was sealed, but was it sealed at the factory or was it sealed later when it's been back and been reworked? Or it's another returner's faulty? I don't know. So we're going to power it up very carefully because the electrolytic capacitors can have lost their charge over 40 years. So I'm going to go and get myself a power lead, which has now turned up. Like they were supplied with the Cybernet series, as in Beta 1000, Beta 2000, Beta 3000. So plug the power lead in. We'll plug the wall speaker into the public address socket. I will plug the test instrument into the test equipment, just in case we're inadvertently going to transmit. And I expect that when these are supposed to be 3.8 watts, it's supposed to do about 1.7 deviation, just like any other new set. But we'll see. I'll plug my test mic in, and I've got about 10 minutes because I'm between church services on a Sunday. So I'm going to make sure we've got channel 9 off, we're in clear mode, we're on delta tune to 0, that's fine. That's fine. Well, squelch to minimum, RF gain to full, dimmer up, mic gain probably up, but we're going to do a PA test. We're going to switch it on at 300. I made sure it's off. Proudly says made in Japan on the front. So we're at 8.5 volts, and we switch on the radio. If we've connected up the, I'm not connected to the power lead, have I? I'll tell you what, this has got banana plugs on, so we'll go straight in with the banana plugs rather than our usual crocodile clips. Power on. absolutely nothing. We've got duff fuse or something in this power lead. I think we've got a dirty fuse in the power lead, and it is lit up, showing 138 milliamps. And it says 32 on it. Right, I'm going to go a voltage. We've got 12. And we'll start the initial test at 12 volts. We are current limited. And we'll switch to public address.
Testing 1 2, testing 1 2, testing 1 2.
Good. So the meter light works. My microphone's falling off. And public address works. So I've got to nip off to another church service in 5 minutes, but I'd like to get through the initial tests we do, and I'd like to do the deviation. And I can turn off the other test instrument which we use for the deviation. Just bring that a bit more forwards like that. Right, let's see what it's doing. So we'll go to our normal meter. We're on the 3 watt scale. We're on channel 20, as you know. We're going to go into transmit. And we're going to switch to CB. And it's waving around about at 2.3. Let's go to 13.8 volts. Still waving around a bit, 2.8 watts. Change channel. Channel 40, 2.8 watts. Channel 1. .85 watts. Back to channel 20. Look at the current consumption. 930 milliamps. Let's look at low power. Checking we're on a 3 watt scale. 150 milliwatts. Back to full power. Look at what the meter says. It says 3.5. Let's look at the frequency. It should have dropped with age. So go to a different camera. .79094. It's well within. Deviation on this test set, for what it's worth, wallow. It says 1.5, which could be true. Let's do the. So I'm going to set the signal generator to be what it's on, but as a fair test, rather than just the radio. 2779094, wasn't it? It's no good setting the signal generator to be right when the radio's wrong. 79094. We'll get there eventually. That'll do. And we'll now connect up the test equipment speaker. think we're going to need an earth on this set, because we have the earth snipped off. Because there aren't many radios that are isolated chassis like these are nowadays. Are we actually in the right socket? No. And we can hear the tone coming through. So we'll switch over to our SINAD meter. And double checking that the RF gain's at full. Put a little bit more volume on so the AGC is fair. 12 dB out of the box, 0.28. .23 for 20 dB, 0.46, squelch to full, 3, 10, 30 is 30 microvolts, which is a bit weak. We'll do the opposite. And we'll see that what the sensitivity is. It's 0.3. Just about. Then we'll put the signal generator on 100 microvolts. We'll see what the S meter reads. And it's bang on the S9, which is exactly where it should be calibrated to on a UK FM CB radio. So far the switches work and the sockets work, but we don't know about all the potentiometers. What I want to do now is I want to do the deviation. I know we're going to do the VCO, but I'll do that when I've come back from church. I'll do the deviation, get that out of our hair. How have they set this AGC feedy backy one? Not how I want it to be is the answer. See, on the European sets they don't have that preset, it's a fixed resistor. So we tend to send that to centre position. And we better disconnect the extension speaker. Wow, it's 1.8 kilohertz, just like we would expect. So we need to adjust that for its central position. Then I'll just see how the deviation is, and then we'll do the deviation on the deviation preset. Wow, that's dropped it a bit. Wallow. That's it. Absolute peak of 2.5. We're going to leave it at that, and we'll come back to it in a few hours. Right, folks, this radio has now been on because I've done a church service, I've had my tea, so it's now been on 3 hours. So I think that's going to be nice and stable. If we put it on channel 40, we'll do the VCO. Put the earth to the tag. I'm on channel 40 with the wrong glasses. Resistor 4 should be 4 volts, and that's 4.28, and on transmit it should be 4 volts and it isn't. So I'm going to waggle this preset round. It's not a preset, it's a trimmer capacitor, and then we'll set it. I want this to be nice and smooth. So 4.1 will do me. Now we'll go back to receive. It's 4.2. I just dropped that a fraction. Transmit 3.8. So that's receive, that's transmit, that's receive, that's transmit. Right, now we'll put the radio on frequency. That's important, so you're going to get channels dropping off at the end, you know, like channel 37 onwards not working, or channel 2 downwards, you know, that, all that kind of malarkey. So, oh, there's a checksum we should do. I'll just show you that, and that is checking it on channel 1. So I'll just go back into that. It should be between something like 1.8 and 2.3. So, the same test point, and it's 2.2 on receive, and it's 2.22 on transmit. So, there you go. Now, those trimmer capacitors can play up now, they're 40 years old. So, that's that done. So, frequency, it was pretty close, 79094 when we started. So let's see what it is now. If I go over to camera 2 on the frequency counter, let's see what we've got. 27, I'll go to channel 20 as well. So now's the point at which we can adjust it. Everything's been warmed up. And again, these trimmer capacitors can play up. The crystal could have dropped beyond what's adjustable with age, but it hasn't. We'll have it very slightly high because they drop with age. So that's that done. I'm not sure why it's only doing 2.8 watts. It came out of the factory doing 3.8 allegedly. Unless this is a reject and it's been sealed in a bag. It's very doable, but it doesn't want tweaking up, it needs finding out why. And the why could be that it isn't at the peak on one of these little transformers. It's going to go to transmit, and I'm looking for, I'm in 3 watt scale, I'm looking for the centre of the peak, not just the peak. We're right at the top of the meter. It's doing 2.95 watts. And it's as stable as anything, which it wasn't when we first put it on. So leaving it on for 3 hours, there's no doubt sorted everything out. Yep, I'd say that was very slightly out. So we're now at 2.9 watts. So the next thing to do Does that one fit? I know we've got those nice ones from Matey. So what we do here is these three have to be temporarily peaked. If you ever come across a set where they're still peaked, it's effectively being left in service mode, because there's a misconception that if you leave it in service mode it's going to work better. Well, of course it isn't. Right, that's taking it beyond the 3 watts. So now, so absolute maximum, I think it was that one which was very slightly out. So that's there. That is spot on the peak. That didn't need adjusting. And there we go. So it's doing 4.8. So never ever leave it thinking you're going to get 1,000,000 miles. So now what we do is the yellow one has to go clockwise for 4 until it gets to 4.4 watts. So clockwise to 4.4. You don't touch that one, and then the green one anti-clockwise. The service manual says for 3.8 watts, but we are allowed 4, and so we're going to have jolly well have 4, whereas they've got to get these radios through customs and they can be spot checked, and if they were at 4.0 something they would be rejected. The whole container would be returned. So they don't risk it, they set them under. So there we go, it's doing a full 4 watts, and it's very nice to see that working so beautifully. The 2 coils which are very, very slightly out was that one and the yellow one. But of course everything's been put to the centre of the peak. So we've got 4 watts on channel 20. Obviously the power consumption will go up, but let's just see where we are first of all. We've got 4 watts exactly on channel 40. I want it to be within 0.1, so far so good, but channel 1 will probably be a bit different. Let's have a look. It is, it's 4 watts. Just goes to show. So that one's worked out nicely. So we'll go to back to channel 20. Look at the current consumption on the meter. It's 1.13 amps. So we've only gone up 115 milliamps, and it's given us another 1.2 watts. So that's because it's tuned right now. Now we've only got 150 milliwatts on low power, and that could be because the adjustment there is dirty. I know it's a new set. Yeah, I think it is. I'm going to use the switch cleaner on it, especially if I could find the applicator, which I can't find today. Yes, I can. These are actually silver plated, real silver, so they're tarnished, and you can see that's tarnished. If I got my fiberglass brush on that, and remember this isn't the contact side, this is just the top side. If I get my fiberglass brush on that, you'll see how it's cleaned it up. So you can imagine it's tarnished on the other side as well. So I've applied the service oil switch cleaner. We're just going to waggle that around so that it's kind of self-cleaning. Now we'll go back into that test. And we've got 400 milliwatts, which is where it's supposed to be, 10 dB attenuator. So, low power preset cleaned. Now none of the others are tarnished, but you see that one is kind of close to rivets and holes. So I think it gets atmosphere. I know it's in a sealed bag, but How sealed is the sealed bag? Right, what else do we need to do? We've done deviation. Oh, we want to just see what the meter says on the front now, because it's supposed to say 4 when it's in a dummy load, especially if it's on full power. So there we go. It's now reading nearly 5. So make an adjustment there. It's now reading 4. And remember that we'll only read 4 when it's in a dummy load or a perfect SWR. So when I'm doing the on the air test later, it might bang across. I'm still doing 4 watts. It might only read 1, but I'm still doing 4 watts. It's relative to SWR. Now the newer sets is pre-programmed into the CPU. So you can take the transmitter transistors out and it'll still say it's transmitting. And that's how they've gone. So that's that done. I think we'll go over to receive now. So I'll reset the signal generator because that's warmed up as well. 779125. So we're now bang on frequency. Which I can put to that strapping wire. Right. It's, oh yeah, it was 1.8 kilohertz. It's now 2.2 to 2.5, and that now reads 4. So that's another thing done. So the first thing we need to do is check this detector is set right. In transit, these can shift, and of course, not only has it come from Japan originally, it has also been in storage for a very long time. So we go over to the oscilloscope and we'll look at the trace. We've got 100 microvolts on the signal generator, which equates to S9. I can just shift that so it's in the centre of the picture. Somehow, where is it? That one. Right, here goes. Was it spot on or not? It was spot on. Okay. I'm going to do the IF first. I normally do the front end first. I'm going to do the IF first. And I'm going to... What we're going to do... I'm doing 3 things here. I'm looking at the oscilloscope, which you've got on the inset picture. I'm looking at the... Mainly looking at this SINAD meter. I'm also going to be looking at the front panel meter. I'm going to turn up the sensitivity just so I can. We already know it was set right. So I'm just going to... It's just so that it's got some movement at this point, as you can see there. That's it. So I'm looking at the SINAD meter primarily, but I want to look at the front meter in case I take the IF the wrong side, because you've got a peak and you could get it the wrong way. So I think we'll start with the one under the wiring harness, which you can't see. You can actually get a tool in there. Absolutely spot on. Now I'm going to look at this one, 455 IF. Not quite spot on. Look at that one. Remember, at the factory they've only got seconds to do the alignment, so all they'll do is they'll have a signal generator on, they didn't have SINAD meters, it'll be to a line, and once it's got to that line it goes on the conveyor belt to the next point. So they don't do all this backwards and forwards that we do, so we're always going to be able to get better receive performance. So we've done the IFs, and I now do need to do the front end. So we'll drop this, so we're not saturating the radio. So we're now solely looking at the SINAD meter. So at the moment it's about at 6 dB, as you can see. So can I get that better? And better is to the left. Worse? Better. Better. Much better. Going on another scale now on the test set. So we put it back to 6 dB. Now we'll adjust the next one. No, that's absolutely spot on. And then we'll adjust the final one. That was exactly spot on. So that was out, yet it was still really good sensitivity, 0.28. So I had a very, very slightly out IF, and quite heftily out, but the set's working fine. So you see where I'm getting to. They will have gone twiddle, twiddle, twiddle to get the line on the meter. Wow, that's looking great. Off it goes on the conveyor belt. Well, we can get more out of it. That's what we've just done. So now, let's see what we've actually got. Well, it's a flying machine. It's 0.2. It's dead on 0.2 for 12 dB. And I'm now between scales, so all I can probably do is put 0.2, 0.2, because I don't actually know. We'll do the 20 while I'm on this scale. 0.31. For 20 dB, 0.31. Right, I'll try and change scales, but it doesn't normally work between the scales. Yeah, I've got 0.22 that way, and if we go to 10 dB, we've still got 0.2. So I dare say we'll put 0.2, and I should put that's less than, and I'm going to put 0.19 microvolts, and I don't think I've ever put that before. So it's been sat there all these years, slumbering and not actually working anything like as well as it could do. So you can see straight away from that we've come from 2.8 watts to 4 watts, and we've come from 0.28 to 0.2. It's already brilliant, but it's now incredible. So how much is this is storage? How much is this carting around? Wasn't it not quite right at the time? I don't know. So we need to now do the meter, which I've of course upset. So we'll put the meter back where it should be, S9 being 100 microvolts. And that's exactly as it was. Tick that a second time now. And now I'll just pop the volume down a fraction. And I'll just show you something else with the tone control, because that SINAD reading we can actually probably improve on by fiddling with the tone control. Squelch. Now I wasn't happy with squelch, it was too weak. I'm going to put the squelch to full. It might have changed now that I've done a retune. So here we are, we're at 10 microvolts. I've got the squelch on the radio at full, 30, 100, that's where I want it to be. So it's now come right. The fact I've put the thing right, the squelch has come right. So now we'll do the opposite and we'll see where the sensitivity was. So turn the squelch down. Threshold, signal generator back on. Just on the edge there. It's 0.34. I'm happy the potentiometers are okay, apart from the one I've just cleaned, but you can see that was tarnished. It's the back of the set, somehow it's got damp in. And when you look at the box, and I showed the box in the initial part of the video, which I've only got the sound to, so we took it out of its bag at the first part of the video, and as I said, there was no picture. That was sealed. The box has seen better days. It's misshapen. It's got mould on it. It's got rusty staples. It's decomposing. So at some point it's been in a damp environment. That can be warehousing, of course. And although that bag was sealed, I can't help thinking it had, of course it had, it's got that hole in it. That's it. That hole in it has caused dampness to get into the set and done that. But I'm going to take the bottom off, which I wasn't going to do, just to inspect and make sure there's no corrosion happening underneath. So I think we'll put the speaker back on. I know the comments will be, now it's just another York 83 like the rest of them. Well, you know, if the customers ask me to do this, it's their business. And I tell you what, if somebody had tried this without the service work, they'd have been disappointed, especially with the transmit. It's quiet as a mouse on transmitted audio, 2.8 watts. That's a 10-1 set. Just turn the volume down. What we'll do is I'll move the screws across, and we'll just check, finally we will just check the factory mic. I'll do that into PA. I'll just unplug the mic because it's going to be inconvenient. I'm not going to clean the case for the customer, but there is signs of mould. But it's the kind of thing you can just put a bit of a cleaner on and it's gone. So I think all the new sets we've seen that haven't been in sealed bags have turned out really to be returns. It doesn't matter because that's what we're here to do. Yeah, we all ought to have a good look at this because it's not being farted about with. Check these are tight, they're very important. Absolutely perfect. There's not going to be any heat related dry joints. You know what, I'm just going to turn the power off. That's a potential one for the future. Good. No corrosion inside the lid. Just a little bit of mould there in the top. What I'm going to do is we're going to, as you know, we didn't get the picture on the first bit of the video. I'm going to put the sound we've got no picture. I'm going to put the sound as a separate thing at the end of this video. Right, so we'll swap the test gear for, I'm still going to check that's clean because I don't want Mr. Chippie to say, is that playing up? We'll just check the springiness of the antenna terminal. It's still 40 years old. And I'll just now get the microphone. I'll put our speaker, our test speaker, into the PA jack. I'll get the roof aerial on, which is the Antron 99. Switch back on, switch it to PA, and get the mic out of the box. It's not tied, so the mic's been got out. I'll carefully operate the PTT so it doesn't break the label. I hope the switch inside there hasn't gone all tarnished and horrible. In the right socket, probably not. That's speaker, that's PA.
Testing 1 2, testing 1 2, testing 1 2 1 2.
That's absolutely fine. So we'll use that at the end of our little test. And we'll go back to our test mic. Switch it back to CB. And we'll see whether that clear normal switch actually works when we do the on-the-air test with Mr. Chippie. Testing 1 2. Right, let's rear it up. There's some debris just there. I'm not going to touch it. 1 on a Roger. Nobody. What I was going to say to you is, if you put the tone to low, it's going to give a better SINAD reading than if it's in high. We've been testing it on medium. I think I've demonstrated that in depth in the past. So there you have it. The York 863 in a sealed bag, 40 years old. And I'm only sorry there was no picture at that unboxing bit. So we'll go over to the sound only. You'll get a test card or a blank picture or next door's cat or something. Thank you for watching the York JCB863 new set from 1981. Hello folks. Today we've got this York JCB863. I've left this till last. Now this is the customer who is in Leicestershire who runs a trucking and farming business. And this is a new in a box York 863. There's quite a tatty box. It's clearly been in a damp environment, but the point is, if I open the box, you'll see that the radio is still sealed in the bag. We'll take it out, and my job today is to unseal this. So shall I use my fingers on it? Yes. There we go. And there we have one pristine York 863. Now of course you don't know that hasn't been rebagged at some time and resealed. It's just got a little bit of, you can just see there, if I get the light right, it's got a bit of mould on the case. I'm not going to clean that, he can. That mould might be worth something. So there we go, we'll get on with the set and get it connected up to the bench and all that. What I'm going to do is not going to use his power lead, because as you can see that's still in the bag, along with the microphone, the bracket and the little fitting kit, and of course the instruction book.